today we're going to start chapter 2. And chapter 2 is kind of different because, like, the first half of chapter 2 is a lot about reasoning, and the last half of chapter 2 is a lot about angles. It's really kind of an awkward chapter. The first 3 sections are all very similar and so basic that really we can cover it in one day. And it looks like you have a ton of notes to go over, but it's going to go super fast. And then tomorrow we're going to look at section 4 in chapter 2. Then on Thursday, we're going to review and quiz. That way when you walk out of here on Thursday, you have a nice long 3-day weekend with no homework. So today we're going to be talking about inductive and deductive reasoning. We're going to be doing something called finding the nth term, which you may or may not be familiar with. So let's start with what inductive reasoning is. Inductive reasoning is the process of observing data, recognizing patterns, and making generalizations about those patterns. Okay, so we're talking about science class here. Okay, what do you do in science when you're doing an experiment? In science, you have things called hypotheses. Well, in geometry, we have what are called conjectures. So these are our educated guesses. Those are those generalizations that you make after all of those observations. So for geometry, it's called a conjecture, but it's basically the same thing as a hypothesis. So here's an example of inductive reasoning. A scientist dips a platinum wire into a solution containing salt, or sodium chloride, passes the wire over a flame, and observes that it produces an orange-yellow flame. She does this with many other solutions that contain salt, finding that they all produce an orange-yellow flame. Make a conjecture based on her findings. So our hypothesis, or our conjecture, is that salt burns orange-yellow. Okay, so that is inductive reasoning. Okay, that's one type. Now, another type that you've been doing for a long time would be something like this. Okay, so consider this sequence, 2, 4, 7, 11. So can we make a conjecture about the rule for generating the sequence? And then we want to find the next 3 terms. Okay, so let's take a look at this. It goes from 2 to 4. Well, that's an increase of 2. From 4 to 7, that's an increase of 3. And then we're going to increase by 4. So we can see our pattern here. We're going to increase by 5, and then we'll increase by 6, and then we'll increase by 7. So that we understand what's happening here, now we can actually apply that pattern. Okay, so if I have 11 plus 5, that's 16. 16 plus 6 is 22. 22 plus 7 is 29. So my next 3 terms would be 16, 22, 29. Okay, again, you've been doing this for a long time. We're just putting a name to it. It's called inductive reasoning. Another example here's more of a graphical representation. So look at the following figures, use inductive reasoning to make a conjecture about what the next figure is going to look like, and sketch it. Alright, so let's figure out, draw the original shape here. Here's all my artistry skills. Alright, so I noticed the blue section is colored in the upper left, and then the right, then the bottom left, the bottom right. Now I'm predicting it's going to go here. Alright, so now, it looks to me like it's just traveling in a circle. So now let's ask, what would that 14th figure look like? What would the 14th figure look like? Alright, well I can use this, assuming it's going to keep going back around. I would assume it's going to go from the 4th step back to the 1st. So it went 1, 2, 3, 4, and then it would go 5, 6, 7, 8, 9, 10, 11, 12, and then this would be number 13 and number 14. So I can make a conjecture here, or my guess, that this one is what the 14th figure would look like. Alright, so that's inductive reasoning. The other type of reasoning that we talk about is called deductive reasoning. So it's the process of showing that certain statements follow logically from agreed upon assumptions and proven facts. Convince someone that your conclusions are valid. It's like what a lawyer does. They stand in front of the jury and they say, ladies and gentlemen of the jury, my client is innocent because of A, B, C, D. Or if they're on the other side, the prosecutor says they're guilty because of, and they list out all the reasons. Okay? So, using logic and going from step to step to step, that is deductive reasoning. Okay? So, here's an example of deduction. So in each segment here, A, B, and C, D are congruent, and they're marked that way as well. So from the markings on each diagram, determine the lengths of A, C, and BD. And then what do you notice about these segments? So AC, if I go from here to here, I can see it is 100. And then BD, if I go from here to here, is 100. All right, not too shocking. Okay, what if I go from A to C here? I have 116. If I go from B to D, I have 116. All right, so what kind of conclusions can we draw? So let's finish this conjecture down here at the bottom. If AD has points A, B, and C in that order, with AB figured to CD, then what can we conclude? Well, we can conclude that, let me put that on our screen. Oh, sorry, wrong button. There you go. All right, so we can conclude that if we add, because AB is congruent to CD, right? We have already said that. I could take AB, add the exact same segment, which in our case is BC, to both sides. I can add the exact same segment to both sides and it will remain congruent. It will remain the same length. It happens both times. Okay, that's deductive reasoning. Another example of deductive reasoning that you've done before, which I'm sure you all love, think back to algebra class. Okay, if we're solving for x, okay, I know you can probably just sit through here and solve for x, but what I want you to focus on, get our little d out of the way, what I want you to focus on is why each step can happen. Okay, so the first thing I would do if I was solving this, I would distribute my 3 to both terms and my 2 to both terms. Okay, so that would give me 6x plus 3 plus 4x plus 2 plus 7 equals 42 minus 5x. All right, so what allowed me to do that? What property allowed me to get 3 times everything in that parenthesis and 2 times everything in that other parenthesis? Well, that was the distributive property. Okay, that's what allowed me to do that. Okay, so now let's think about our next step. For me, I would just combine my like terms on each side. So I'd have 10x plus 12 equals 42 minus 5x. Okay, so there what I did was combine like terms. Okay, combine like terms, we call CLT. Combine like terms. It's something we use quite a bit, so just call it CLT. It'll save you a lot of headaches. A lot of writing. Okay, now mathematically what I would do next, I want to get this negative 5x to the other side. So in my brain, I would not write this step down, but in my brain I'm thinking, okay, I need to add 5x to both sides. If I do that, and it was 15x plus 12 equals 42. So what allowed me to add 5x to both sides? Okay, back to your properties of equality. Remember it's the addition property of equality? Okay, and I would simplify that by just writing that out, or shortcut it to the addition sign, POE, property of equality. Okay, then we have, again, back to my equation, I need to get rid of that 12. So in my mind, I'm thinking, okay, I need to subtract 12 from both sides. That's supposed to be minus 12 there. Okay, so that means I have 15x equals 30. So what allowed me to subtract something from both sides? It's the subtraction property of equality. Okay, the last step, I know I need to divide those sides by 15, right? So in my head, I'm thinking I'm going to divide by 15. So I have x equals 2. And what allowed me to go to that step? The division property of equality. Okay, I'm not going to be making you do a ton of these, but I just want to show you this is just yet another example of deductive reasoning. Again, a lot of this reasoning you've been doing for a long time. I'm just putting specific names with it. All right. So now, the next thing we're going to do is do a little bit of that inductive reasoning, but then we're going to kind of take a little bit further. So let's consider this sequence here. 20, 27, 34, 41, 48, 55. I want to find the next 3 terms. Okay, so let's do our constants you've always done. You know, going from the first term to the second term, that's a plus 7. Going from 27 to 34, that's a plus 7. Plus 7. Okay, I'm seeing a pattern here. So I can definitely find the next three terms, right? If I ended at 55, okay, if I want to add 7 again, when I add 7 again, I get 62. Add 7 again, I get 69. Add 7 again, I get 76. So I can find those next three terms. That's not a big deal. But what if I wanted to know the 200th term? Okay, I can add 7 pretty well, I think, but doing that 200 times and losing track of where I am, it's just a waste of time. It's ridiculous. Okay, so we need to think about this logically and algebraically. So we're going to create what's called a function rule. Okay, a function rule is an expression that allows us to find any number term that we want. It's called the nth term, meaning any term that we want. And I think you may have done this a little bit in algebra too. But as a quick reminder, if you don't forget, the equation on the line is y equals mx plus b, or f of x in our case, equals mx plus b. And what we did have there was a linear function. Today everything is going to be a linear function. Tomorrow it is not necessarily going to be a linear function. So as a quick reminder, slope is the m value. Remember, slope means how something changes. Okay, keep that in the back of your mind. Slope is how it's changing over time. Okay? And then the y-intercept is where x equals 0. It's the 0 term, where x equals 0. Okay? Those two ideas here are going to make finding that 200 term much easier. All right, and I spelled this all out in your notes just so you have it all written down. So just kind of follow along here. Think about, we had term 1, 2, 3, 4, 5, 6. Okay, I just numbered them in order. And so we start with 20 and 27 and so on. And I have my plus 7, plus 7, plus 7. So I've shown you this pattern here. Okay, that shouldn't be a shock to you. So it has a constant change of 7. Remember we just said what change represents? Change is slope. How that line is changing is called slope. So I know the slope of my equation, so far I'm going to have y equals 7x, and I need to know the last part here. Okay, so how it changes, how it's constantly changing, that is my slope. Okay, now, to find that y-intercept, I'm going to actually just write in the 0 term here. Okay, so notice I've added this column right here. I've added this column for the 0 term. And I just need to think backwards. What if I added 7 got me to 20? Well, that's going to be 13. Okay, so if I follow that backwards, I can find my 0 term of an x equals 0, the y-intercept has to be 13. All right, so that 0 term, remember that is the y-intercept. So let's think about what we have here. I know my slope is 7. That's how it's constantly changing. My y-intercept with the 0 term is 13. So therefore, my function rule here can be 7x plus 13. So the x then represents what step, what number of terms. So like we just found before, I gave you the first 6 terms, and we found the 7th, the 8th, and the 9th term. Well, remember I asked you what's the 200th term. Okay, so we can use that function rule. We can use our function rule, so we have f of x equals 7x plus 13. Okay, I can use that function rule to find f of 200. Which means I need to take 7 times 200 plus 13. That gives me 1400 plus 13, or 1413 in the 200th term. Okay, so that function rule saves us a ton of work. Hopefully you did, I think last year I remember students saying they did a lot more of that in Algebra 2, so hopefully that'll be easy for you. So let's work on here, let's find our function rule. We're just going to work on finding the function rule. Okay, so let's think about how it's changing. So from 7 to 2, that's a decrease of 5. 2 to negative 3 is a decrease of 5. A decrease of 5. A decrease of 5. A decrease of 5. Now I'm going to add, I'll make our little table here because we go. We'll divide it up. So that was our first term, our second, our third, fourth, fifth, and sixth term. Okay, so I know my constant change was 5, which means my slope is, my constant change was a negative 5. So my slope is a negative 5. Now remember, I want to go backwards to that 0 term. So I need to figure out, what did I subtract 5 from in order to get 7? Well, that was 12. So my y-intercept or my z value is 12. So f of x or f of n, whatever you want to use, is going to be negative 5x plus 12. All right, so you have a worksheet that kind of goes through all this inductive, deductive, reasoning, that kind of stuff, and then practicing finding different terms and finding the function rules. So that is your homework. If you get it done early, you're welcome to get Chromebooks out. There's no time to continue to work on your 3D printing stuff.